Hypersonic weapons can travel at a speed of at least 5 times the speed of sound. That's around 3,800 miles per hour. Air Force Secretary Frank Kendall says he's not satisfied with the pace of development for those hypersonic missiles and says there's some progress on technology, but he wants it to be even better. Mark Lewis is Executive Director of the Emerging Technologies Institute at the National Defense Industrial Association. He's former Director of Defense Research and Technology at the Pentagon. Mark, welcome to the program.
Thank you for having me.
So has the Air Force soured on hypersonics?
Well, I would certainly hope not. We have studied hypersonics extensively. We know that it's a critical capability for the future of national defense. So I would actually hope that they're going full speed ahead.
Why is hypersonic weapon development taking so long?
Well, I would argue it's more due to politics and bureaucracy than technology. We have the technology. We flew the first hypersonic air-breathing system, the X-51, 11 years ago. So it's a technology that we've tended to invest in. We start, we stop, we have programs that don't quite come to fruition, we discontinue them. It's actually been rather frustrating.
You mentioned air breathing. Explain in non-technical terms how these things fly and how they get to be so fast.
So there are two ways to power a hypersonic vehicle through the atmosphere. The first is with a conventional rocket. I light off a rocket, I get it up to speed. In many cases, I'll have the hypersonic thing actually separate from the rocket and glide the rest of the way. The other way is with a jet engine. An engine that has a hole in the front, it's got an inlet, it swallows air as it travels, and it uses the oxygen in the air to burn with the fuel. That's why we call it air breathing.
What do we use these weapons for? Give me a use scenario where we'd have to deploy one.
So there's a very wide range of applications for hypersonic systems. It could be a very rapid response, relatively long-range weapon for precision strike. It could be a tactical system, a cruise missile that comes off the wing of an airplane, or that's launched from a surface ship or a submarine to do a rapid strike, often we would envision it as a precision strike against a high-value target.
And how far along are we with the technology? Give me a timeline. When would we see these built and deployed and used?
Well, our goal, actually, when I was in the Pentagon, our goal was to have these built and deployed by the end of this decade. And again, it's really not a technology hurdle. It's a financial issue, and it's a programmatic issue.
So you're not going to give me a timeline?
No, so it's difficult to give a timeline. You know, just this past weekend, Raytheon flew their Hawk hypersonic demonstrator, the high-speed air-breathing weapons concept. Basically, that showed once again that we know how to build these systems. We know how to build the engines. We know how to build the airframes. We understand the materials that are required to build these. We can design the guidance systems that will control these systems. The next step really is first to get them out of the demonstration phase, the development phase, into the actual production phase, and then produce at scale. Ultimately, our goal was, and hopefully still is, to produce not a few handful of these weapons, but to have them in the hundreds or actually in the thousands to provide an adequate capability and deterrent.
Okay, but we need to talk about the money. If you're talking about thousands of these,
right.
How much does one cost? So
a big issue with hypersonics is the cost of these systems. And in fact, I think one of the great misnomers of hypersonics is that it will be inordinately expensive. A system such as that Raytheon just flew this weekend, we envision about $2 million a copy. That's about twice the cost of a conventional cruise missile. But if it's much more effective, the cost per effect can actually be much lower than with hypersonics.
But also there's the R&D that goes into it. Doesn't that add substantially to the price?
So it does, and that gets amortized. But I would point out the department has put a tremendous amount of funding now into hypersonics. The most recent Pentagon budget, the 22 budget, reconfirmed the investment the department is making. It's quite significant. I like to say it's almost a NASA's budget worth of funding over the 5-year plan in order to get us to hypersonics at scale.
So I was going to ask you about Congress. Are they fully on board? Because they're the ones that are going to have to fund this.
So I would say we get tremendous support from Congress. There is actually a hypersonics caucus in the Congress. Congress has been extremely aware of the capabilities of hypersonics, and also I think they've been concerned about developments overseas, work that China and Russia have done on hypersonics. They've been briefed on their activities, and I think they've been very responsive and very supportive of the department's efforts.
Tell me about Russia and China. right? Because these are going to have to counter them, deter them. What do they have in terms of hypersonic weapons?
Correct. Well, the first thing I would say is we would want hypersonic systems regardless of whether Russia or China were developing them. But the reality is Russia and China are developing these systems. Russia has built in their legacy from the Cold War. They've developed, and they've been very, very bold about talking about their systems. They're developing maneuvering hypersonic systems to augment their ICBM fleet. And these would be nuclear systems, by the way, which I'll point out, we are not doing nuclear hypersonic systems. China has invested very, very heavily across the board in hypersonics. I like to say we did their homework for them. They built on our capabilities, they read our papers, they followed our research, they followed our developments, and now
Wait, did they follow it or did they steal it?
Both, actually. So some of it was open literature, some of it was just frankly stolen. And they also read our documents that we said hypersonics is a really important future capability. And they believe what we said. I wished we had believed it a little bit more. And so China has invested heavily in, they've built wind tunnels, they've invested in their universities. And one of the advantages of a top-down dictatorial government is they can get things done often very efficiently.
All right. Well, Mark, we're going to take a quick pause here. We're going to come back and talk about something else, okay? Spacecraft today can only travel so far and so fast with current rocket technology. But nuclear power could be the key that allows spacecraft to fly farther and faster. The Department of Defense and NASA will refocus on nuclear power systems for future space capabilities. Mark Lewis is Executive Director of the Emerging Technologies Institute at the National Defense Industrial Association. The U.S. government had worked on nuclear-powered rockets back in the 1960s. Why are we just now rediscovering this idea?
So you're exactly right. There was extensive work done, not just research, but development, and engines were built. And there were even plans in the 1960s that we would have nuclear rockets that would power the later Apollo missions to the moon. And then ultimately they were seen as the engines that would get us to Mars. In the early 1970s, the White House lost interest in, I think they lost interest in the Apollo missions, but then lost interest in nuclear power, and support waned.
And so that technology kind of just got shelved? I mean, is it still valid? Is it still useful? Do we have to reinvent the wheel now?
So the technology was shelved, but we actually don't have to reinvent the wheel because we pretty much remember a lot of the work that was done. So there were two key programs. One was a program called Kiwi, which was a joke because it was a kiwi is a bird that doesn't fly. The Kiwi rocket engine never flew, so that was a joke. And then there was a program called Project Nerva, which was the more advanced version. And under Nerva, engines were built, tested, they were run. Some of the Nerva engines were run for almost half an hour. The engines could be started and stopped. So it was everything that you need for a space propulsion capability.
So what new capabilities would nuclear thermal rockets enable? What would we be able to do with nuclear?
Here's the key thing about a nuclear thermal rocket. It gives you twice the thrust for the amount of fuel that you consume compared to a chemical rocket. So you can think of it as better bang for the buck. In aerospace engineering terms, we refer to the specific impulse of a rocket. That's the amount of thrust you get divided by the rate at which you burn fuel. So a nuclear rocket basically gives you more thrust. You get a bigger push for the amount of fuel that you're burning.
Now, if you've got nuclear power, you're going to need a nuclear reactor.
Correct.
Is that safe? I mean, you're talking about launching a nuclear reactor into space. Nobody wants to see some sort of Chernobyl accident going on up there.
So in fact, that's one of the first questions that always comes up when people talk about nuclear power in space. The reality is we can build reactors that are absolutely safe, that can survive the worst launch accident and not spread radioactive material. In fact, we already launch radioactive material on a fairly regular basis. We power our spacecraft, especially spacecraft that operate in the distant solar system, on something called RTGs, radioisotope thermal generators, which is a lump of radioactive material that decays, gives off heat, and that heat is turned into electric power. Those are actually more dangerous than nuclear reactors, and yet we launch them and we do so safely.
So how important is this technology to military strategy? How will this change things for the Pentagon, if at all?
So one of the things that we've learned over the past decade or so, we've realized space is not a sanctuary. We used to think that if we launched something in space, it was safe from attack. Now we know that's not true. Russia, China have capabilities. And one of the ways you might want to respond to an attack is to get out of the way. And a nuclear rocket has the potential to give you high thrust so you can maneuver out of the way of an attack. It also gives you the ability to change your orbit, change your trajectory, so you're less predictable. So it introduces a degree of safety in space.
Can you give us kind of a non-technical explanation of how this actually works, how you could use nuclear power to thrust a rocket for propulsion, for power?
So in principle, a nuclear thermal rocket is a very simple device. You have a nuclear reactor, which is essentially just a heater. It's generating heat, and then you flow some fuel, some liquid through it. Hydrogen turns out to be the best fuel to use. It gets really hot, expands out a nozzle, and you get thrust.
You know, I always have to ask you, what are our adversaries doing, right? Is China and Russia doing this? Are they using nuclear power in space?
So we don't know about China. We do know that Russia actually had a long history of putting nuclear reactors into space. In fact, a few decades ago, we the United States, bought some Russian reactors. We're looking at the possibility of putting their reactors on our spacecraft after the fall of the Soviet Union. Ultimately, we didn't do so, but they've had a long history in this area.
So, you know, we said that you can use this to go farther and faster. Mm-hmm. Is this what gets us to Mars?
So I actually happen to think nuclear thermal is a really good way to get us to Mars. And there are other solutions. You could do something called nuclear electric. That's where you have a nuclear reactor, but instead of heating something like hydrogen, you generate electric power, and then you have an electric engine. The advantage of nuclear thermal is, because it gives you such high thrust, it gets you to Mars faster. And it also gives you more options. You can abort your mission more easily with nuclear thermal. So if something goes wrong, there's a solar flare, someone gets sick on the mission, it's easier to turn around on a nuclear thermal rocket than it is on any other engine.
And we definitely need to get back, because I've seen that movie.
Yes, yes.
Nobody wants to get stuck on Mars.
No, you do not want to get stuck on Mars. That is absolutely right.
All right. Well, Mark, thank you so much for being on the program.
My pleasure.